Assalamualaikum and greetings to our Mechanic of Machine lecturer, Ms. Shazwana. In this video, we will present our report, The Applications of Mechanic of Machine in Gym Equipments. In this study, the gym equipments that we will study is exercise bike or stationary bike and treadmills. Treadmills is a workout machine with a belt that loops around and is powered by a motor. Meanwhile, a stationary bicycle is a piece of equipment used for cycling exercises indoor. From the equipments above, we will study the applications of friction and wear in treadmills. Meanwhile, the exercise bike uses the power transmission concept. Now, I will explain the background of the study. Exercise bike is a well-known and often simple to use type of cardiovascular equipment. Both a chain drive and belt drive are part of mechanisms allows the locomotion and a transfer of power within a particular piece of machinery. Exercise bike initially uses the chain drive system to transmit power in its system. However, latest exercise bikes utilize belts to power the pulling system, while others use chains. The flow of energy from its source to the place where it is used to do work is known as power transmission. While exercise bike uses the concept of power transfer, a treadmill can be tied to friction and wear concept. When a treadmill's surface is inclined, we may observe that the friction idea at work. In order for a treadmill to provide a smooth motion and minimize wear and tear on its system when inclining, the concept of friction is crucial. The direction of motion that two moving surfaces in an inclined position normally rub against one another is usually the opposite. The basic theory of power transmission. Machine parts perform specific purposes. The power transmission process transfer motion from one shaft to another. The belt drive systems, also called friction drives, because power is transmitted as a result of the belt's adherence to the pulley. Belt drives are also easy to install, require no lubrication, and dampen shock load. In power transmission, velocity ratio, work done, angle of contact, and length of belt need to be considered to calculate and analyzing every problem related to the principle of power transmission. Friction is the resistance to relative motion between two bodies in contact. Basically, the situation of running on an inclined treadmill will be related with motion up the plane. Basic parameters needed in the calculation and to determine the friction motion up the plane are including force, torque, and efficiency. These are the formula that is used to calculate and analyzing every problem related to the principle of friction.
Now, we will move to the analysis and calculations. So as you can see in the slide, we have the first problem statement here, which is for the power transmission chapter. So if you want to read the problem statement, you can pause the video. Since the length of belt is given, which is 54 inches, from that we can use the formula for the length of belt to find x since the x is unknown. So first thing, we have to change the unit from inch to millimeter, like in the slide. And then we use the length of belt formula to find the x. As you can see in the slide, we have to multiply with an x to use the quadratic equation to find x. And lastly, from the calculation, we choose our x to be 376.81 mm in length, and now we can include x in formula of limiting angle. From the formula of limiting angle, we can find that alpha equals to 6.58 degree. So we have to change the degree into radian to use it in the angle of contact formula. So with that, the angle of contact equals to 2.904 radian. After that, we need to find the tangential velocity of the driver pulley. Since we already have the speed of the cyclist ride a bike, which is 90 rpm, we have to convert the speed to angular velocity, then finally convert it to tangential velocity. So as the angular velocity, we can find it directly, and we get tangential velocity is 9.424 radian per second. And for the tangential velocity, we get 1.131 meter per second. With all the value that we get before, we can find the tension of driver pulley T1 and the tension of driver pulley T2 as well using the formula of maximum power. As you can see in the slide, we have calculate the value, and T1 equals to 99.4 Newton. For the centrifugal tension, TC can be found using the following measurement. And from that, we can get the value of T2, which is 46.04 Newton. And now we move to the second problem statement. So if you want to read the problem statement, you can pause the video first. From the problem statement, we need to calculate is the horizontal force F by using the formula below. F equals to F1 plus F2, R equals to R1 minus R2. And now we can find the F2 and R2 since the weight of the jogger is given. And as you can see in the slide, the value of F2 equals to 202.8 Newton and R2 equals to 707.2 Newton. And after finding the value of F2 and R2, we can find the F by using the coefficient of friction formula, and the value of F equals to 167.44 Newton.
Okay, now let's start with the first discussion. So basically, all of the question has been discussed by KHAIRUL ARIF, which is he already answered for the calculation and the analysis. So I will discuss a bit detail about the calculation. Okay, first of all, the two pulleys and the flat belt are the mechanism that is used in a stationary bike. First, we have to find the S unknown. So what is S unknown? S unknown is a diagram that I have sketched for you to find the S that between both of the two pulleys. Okay, after we have find the S unknown, we will next we will find the angle of contact. All the explanation has been explained by KHAIRUL. So I will move to the next, which we will calculate the tangential velocity by using the angular velocity. And the last step is to calculate the maximum tension, which is T2. Overall, we will get the answer for the T2 and for the problem statement 1. Moving on to the second discussion. So the second discussion is about the treadmill and incline plane. So treadmill is inclined and they will have a gravity that acts upon the treadmill, upon the users. So first of all, we have to change the weight of the user into Newton, which kg to Newton. So the weight of the user will times 9.81, which is the value of the gravity. After getting the value for the weight, we have to calculate the coefficient of friction. So the inclined plane is 16 degrees and it will have a coefficient of friction that acts on the inclined plane, and also the force from down acts upon the user, which the runner. So moving on to the next step, we have to determine the value of F2 and R2 since the weight has been given. F1 and R1, we can find it from the question. All the explanation has been explained by KHAIRUL. The last step is use the formula of coefficient of friction to calculate the force. It's me again. Now I'll make the conclusion for overall this group project. So both stationary bike and treadmill is incorporate several mechanics of machine principles. Both equipment give a very good benefits to humans in order to maintain their health and stay fit every day. Incline treadmills include of weight, coefficient of friction, and force. Stationary bike use flat belt drive to transfer the power system to make sure that the system works smoothly. Finally, the principle of mechanic machine can be applied on stationary bike and treadmill. Last but not least, we would like to thank to Puan Shazwana for all the knowledge that she has been shared to us. Thank you.